Welcome back. In this video, we're going to explore L'Hopital's rule. L'Hopital's rule is a rule to evaluate limits that we might not otherwise be able to evaluate. So if we have the indeterminate, undefined form of a limit is going to be 0 over 0 or infinity over infinity, we can apply L'Hopital's rule. And what it says is that if you take the limit as x approaches a critical number of the derivative of the top equation over the derivative of the bottom equation, if that converges to a limit L, then the original limit is also L. It works for infinity over infinity as well. Always make sure you check to make sure that you have the indeterminate undefined form of it. Like if I plug in 0 here, I end up with 0 over 0. So I can apply L'Hopital's rule. So the limit as x approaches 0, take the derivative, would be e to the x plus the sine of x over 4 cosine of x. If I plug in 0, I end up with 1/4. So that means the original limit is 1/4. Continuing on with my examples, again, if I plug in 0, I get 0 times 1 over 0 plus 0. So again, 0 over 0. So then I can have the limit as x approaches 0. Take the derivative. I got to use a little product rule. So it's going to be cosine of x times cosine of x plus sine of x times negative sine of x over 1 plus cosine of x. If I plug in 0, I get 1 here, I get 0 here, and then I get 1 plus 1 down there. So it's 1/2. So then the limit of the original equation is also 1/2. Continuing on, when we have x ln of x, if I plug in 1, the ln of 1 is 0. So I get 0 over 0 again. So again, apply some product rule. The limit as x approaches 1 of the ln of x plus x times 1 over x, and that's over 2x. And when I plug in 1, the ln of 1 is 0. This is 1, so I end up with 1/2 again. A couple of new types of problems for my last two examples. The first one is I'm going to approach pi over 2. Pi over 2 are vertical asymptotes for both secant and tangent, so these are both going to go to infinity. So this one's an infinity over infinity. I'm going to approach it from the left because it has a vertical asymptote there. When I take the derivative, I can apply L'Hopital's rule, and I'm going to take the derivative. When I approach pi over 2 from the left-hand side, it's going to be a 4 secant squared of x over the secant of x times the tangent of x, which then when I plug in pi over 2, I still have those vertical asymptotes. But what happens here with the trig is I can simplify it. So this one secant cancels with that, and I end up with 4 secant of x, and that's divided by tangent. So I'm going to write it as times cotangent of x. And if I write those in terms of sine and cosine, I end up with 4 secant of x. I just said sine and cosine. 4 times 1 over cosine of x times cosine of x over sine of x. The cosines will drop. The sine of pi over 2 is 1. So 4 over 1 is just 4. And then finally, in my last example, in this one, is one of those ones where if you apply L'Hopital's rule, sometimes when you apply it, you still end up with 0 over 0. And you can keep on applying it. I think in this one, I end up having to apply it 3 times before I get there. If I plug in 0, I end up with 0 over 0. Okay, that's fine. So I can apply L'Hopital's rule. So if I take the limit as x approaches 0, it's going to be 2 cosine of x minus 2 cosine of 2x over 1 minus cosine of x. If I plug in 0, I end up with 0 over 0. I get 2 minus 2 over 1 minus 1. So I apply L'Hopital rule again. Limit as x approaches 0. This is going to be negative 2. It's going to be sine of x plus 4 sine of 2x over the sine of x. I plug in 0. I get 0 over 0. And then finally, I do it again. The limit as x approaches 0. This is going to be negative negative 2 cosine of x. And then it's going to be plus 8 cosine of 2x over the cosine of x. And if I plug in 0, I end up with 6. So that means my original limit is 6. All right, so I'll clarify some more in class. Head down that road on this problem set and be done with this second unit on derivatives.